Math 2 Semester 2 Standard 4 Mastery Exam Review. Number 1, true or false? The point -2, 6 is a solution to the system of inequalities below. Show work to justify your answer. So your x value is -2 and your y value is +6. So you're going to plug in -2 wherever you see x in the two inequalities below, and you're going to plug in 6 wherever you see a y in the two inequalities below. So it'll look like this. 6 is greater than the absolute value of 2 times -2 minus 1. And then the other inequality will be 6 is less than or equal to 1/2 times -2 plus 7. And again, a reminder, the x was -2, so I put in a -2 in parentheses wherever there was an x. And then the y was a 6, so I put a 6 in for y. From here, we're just going to want to simplify both inequalities. So on the right side, the absolute value of -4 minus 7, and then the absolute value of -4 is +4. 4 minus 7 is -3. So is 6 greater than -3? Yes, it is. So that works out. For the other inequality, 1/2 times -2 is -1, and then -1 plus 7 is 6. So is 6 less than or equal to 6? Yes, it is. So at the very end of this problem, it was a true or false. So true, because -2, 6 is a solution to that system of inequalities. For number 2, determine if the point 37 is a solution to the system of equations below. Justify your answer. So where we see a y, we're going to want to plug in 7. Where we see an x, we're going to want to plug in a 3. So I see an x, I plug in a 3. I see a y, I plug in a 7. So again, to kind of color code that, make sure we're on the same page, x is 3. So x, x, x. And then x, x, so all those are 3s. And then y is 7. So y is 7, y is 7. From here, we're just going to simplify. So 7 equals 7, that's a true statement. And then 2 times 3 is 6. 6 minus 7 is -1. So -1 does not equal 1. So no, 3, 7 is not a solution. So no. And as far as the justify your answer, the work that we have shown justifies our answer. So I'm not going to bother justifying it in words because the work shows us that it's not a solution. Number 3, given f of x equals 2 times the absolute value of x, determine the value of f of -1. So simply take -1, plug it in for x. So the absolute value of -1 is +1, and then 2 times 1 is 2. So f of -1 is 2. Number 3, given g of x equals x squared minus 1, determine the value of g of -2. So we take g of -2, and wherever we see an x, we're going to plug in a -2 in parentheses. -2 squared is 4, 4 minus 1 is 3, so g of -2 is just 3. Number 5, if f of x equals 3/2 x squared minus 2x, find f of 4. So take 4, plug it in for x. Whoopsies, that is not correct. So plug 4 in for x, and then follow order of operations. So you have to do 4 squared first before you do 3/2 times 4. So 3/2 times 16 minus 8. And then to make your life easier, think of the 16 as 16 over 1. And then if you want to, you could reduce. 16 divided by 2 is 8. So then in the front there, 3 times 8 is 24. 24 minus 8 is 16. So f of 4 equals 16. Number 6, we're going to plug in -1 wherever we see an x. So g of -1 is -1 plus 3 all over -1. So negative 1 plus 3 is 2. And then 2 divided by negative 1 is negative 2. So g of negative 1 is negative 2. Number 7, simplify. So we're going to distribute to get rid of our parentheses. So negative 6x plus 30, and then minus 15x plus 25 plus 1. And then we're looking for some like terms. So negative 6x minus 15x is negative 21x. And then 30 plus 25 is 55, plus 1 is 56. Number 8, simplify. So we're looking to combine like terms. Keep in mind that like terms are the same variable raised to the same exponent. So 4x squared and negative 5x squared match because they're both x squared terms. So we want to add the coefficients. Coefficients are the numbers in front of the variables. So 4 plus negative 5 is negative 1x squared. Then 3x plus 4x is 7x. And then last but not least, negative 7 plus 8 is 1. If you left the negative 1 in the front, I wouldn't mark it wrong, but I typically like to drop that negative 1 because it's more simplified to not have it there. Number 9, simplify. So we want to distribute to get rid of the parentheses. So 4 times 1 is 4. 4 times negative 2x is negative 8x plus 8x. And then that negative sign is like a negative 1 that needs to be distributed. So negative 1 times x is negative x. And then negative 1 times 2 is negative 2. Now we're looking for like terms. So negative 8x plus 8x is 0. And then there's another x term right there. So negative x, and then 4 plus negative 2 is positive 2. On 10, we are simplifying, so we want to combine like terms. I see a 5x to the third plus a 4x to the third, which is 9x to the third. I see a negative 2x squared minus 4x squared, so negative 6x squared. And then I see a 1 and a minus 5. Notice when we're combining like terms, we do not change the exponents on the variables. We just leave them alone. Number 11, distribute. 4 times 2 is 8. X squared times x is x to the third, because when you're multiplying like bases, you're adding the exponents. And there's that invisible 1 as the exponent on the x inside the parentheses. Then 4x squared times 1 is 4x squared. Number 12, distribute. Negative 2 times 3 is negative 6. X to the fourth times x squared is x to the sixth, because 4 plus 2 is 6. Then negative 2x to the fourth times negative 2x is positive 4x to the fifth. Because remember, there's an invisible 1 as the exponent on the x. Then, negative 2x to the fourth times 1 is negative 2x to the fourth. And then that should be it. Number 13, simplify each expression. So absolute value of 2 minus 8, you always want to work inside the absolute value bars first. So 2 minus 8 is negative 6. Absolute value of negative 6 is positive 6. Part B, work inside the absolute value bars first because of order of operations. It counts as grouping symbols or parentheses, so you have to work inside the parentheses first. So 4 minus 5 is negative 1, and then the absolute value of negative 1 is positive 1, and then negative 2 times 1 is negative 2. Part C, work inside the absolute value bars first. So 5 minus 3 is 2. In the back, negative 1 squared means negative 1 times negative 1, which is positive 1. Absolute value of 2 is 2. Negative 4 plus 2 is negative 2. And then negative 2 plus 1 is negative 1. 14. Determine the inverse of f of x equals 2x minus 1 by completing the problem below. So they have it started for us. F of x is the same as y, and then you switch x and y, and then you just solve for y by doing order of operations backwards. So I have x plus 1 equals 2y, and then I undo multiplication by doing division. So x plus 1 over 2 equals y. And then if I want to get fancy, I can use the inverse notation. So I could do f inverse x equals x plus 1 over 2. I would accept either notation on the mastery exam. For 15, same concept. They have a function, and we're supposed to find the inverse. So they switch, or they let g of x equal y to start, and then they switched x and y for us already, and then now it's our job to solve for y by doing order of operations backwards. So we need to subtract 6 from both sides of the equation, and then we're going to undo multiplication by doing division. So we get x minus 6 over negative 3 equals y, or if I'm using the fancy notation, g inverse x equals x minus 6 all over negative 3. Number 16, determine h inverse of x. So again, same problem. They start us with the equation. They let h of x equal y. Then they switch x and y for us. So they just have it started for us because that's technically power standard 3. So now that everything's all set, we have to solve for y by doing order of operations backwards. So I'm undoing division by doing multiplication. So to get rid of that 4 in the bottom, I'm multiplying both sides of the equation by 4. Then I'm getting rid of that 1 by subtracting 1 from both sides of the equation. And then there you go. And if I'm using my fancy notation, instead of y, I plug in h inverse of x. Last one, number 17. So they have the problem started for us. Sorry, there's a little tiny typo there. That should be a j of x instead of an h of x. So they let j of x equal y, and then they switch the x and y for us, and now we get to solve for y. So to get rid of that 2 in the denominator, I'm going to multiply both sides of the equation by 2. That cancels out the 2 in the bottom. Then I'm going to add 4 on both sides like that. 2x plus 4 equals negative 5y. And then divide by negative 5 to undo multiplication. So we get 2x plus 4 all over negative 5 equals y. Or again, if we're doing our fancy notation, j inverse x equals 2x plus 4 all over negative 5. And that would be our answer.